get us started, so something I've been really interested in recently, and it is related to kind of what, I don't want to be in front of the screen there, it's related to what Matthew kind of talked about, which is kind of the direction Snag's going and the kind of application and the kind of user experience we're trying to build for our users. I've been interested in WebSockets and have been working a good bit on building out and kind of scoping out our WebSocket architecture that will allow us to improve our user experience and make being on snagajob.com kind of a more interactive experience. So since we have people of all different levels here, we've got a few college students and we've got people with way more experience that are far better engineers here than me. I'm going to start with some basics about WebSockets and why they're powerful and why you might use them for your next project. But before, I always put this slide in there because I forget. I get like wrapped up and I forget to mention that we're hiring. So I work on the DevOps team. Zach back there, he used to be the host of AWS Meetup before he moved up to Raleigh. And so Zach, you're gonna have to start a Raleigh AWS Meetup, and we'll have I'll travel up there for you, man, and come to your meetup, man. But we've got a few open positions right now, and we've got some more that are kind of opening up soon. So just be on the lookout. But on our DevOps team, we've got one open, and also site reliability engineers. We're trying to find one here in Charleston to go with one of my colleagues, Ryan, back in the corner. Would love to have some friends to work with on the site reliability engineering team. So let me know. So today, Snagajob, for the most part, works the same way as basically 99% of the internet, which is we have kind of a standard client-server model. So the client would be me on my laptop, and the server is snagajob.com. So I go to snagajob.com, I send a request out, that goes to some server out there somewhere, and that server sends me back a payload, some data that loads one of our websites. And this is all well and good, but it's more kind of like this. We have Jim in this example is our user, and Jim's logged into snagajob.com, and he's making a request, standard client-server kind of model. But behind the scenes, we have actually hundreds of servers, and we have dozens of databases. And so it looks like Jim's reaching out to a single server or a single IP address, but really behind the scenes, a whole lot more magic happens that generates the user experience, the data that Jim gets back. And it's kind of tailored specifically to Jim. The problem with this model is that Jim's request is right now. Now Jim's request is over. And so Jim's gone as far as we're concerned. So once he loads the page, we don't know if Jim's still there. Jim could have gone and gotten the coffee. Jim could have closed his laptop. We just gave Jim search results or loaded the page, or he just applied for a job. But as far as we're concerned, Jim's essentially gone until Jim reaches out, because he is in control of this whole experience, and makes another request to us. And this is fine if it was just Jim on our website. But there's more than just Jim on our website. We have thousands of users interacting with our website, or tens of thousands of users on our website, 24/7, 365. And those users are more than just Jim looking for a job. They're managers hiring people at Snagajob. They're people who work for HR departments. And they are all doing things related to the hiring process. And what they are doing is potentially very likely related between the different users. So in this example, Jim isn't alone. We also have Susan. Susan's also on Snagajob or People Matter, one of our websites right now. Now Susan, in this case, Susan could be a hiring manager. She may manage Chick-fil-A or something, and they've got some job postings up. And Susan is put up a job posting, and she's waiting to hear back, wants to get some applicants. And Jim could be applying, but Jim and Susan's requests are at different times. So if Jim applies after Susan's last request, we don't really have a good way to tell Susan that relevant information outside of sending her an email, or she has to come back and reload the page. So that is where kind of WebSockets come in. And the reality is, behind the scenes of Snagajob, we have a very fluid environment. All of these users are using our website, and they're changing the data that drives snagajob.com every click. They are modifying postings, they're applying for jobs, they're taking shift work so that they can work a shift really quickly, or work a shift for tomorrow to pick up some cash on the side. And all of those changes that is changing the data are driven by events. So when someone submits or adds or modifies a job posting on our website, that is an event that lets us know and triggers a series of other things that actually modify the posting and update all the relevant downstream systems. What that, then that's great, and that's kind of how our architecture has been, but that hasn't been leveraged to improve the user experience as much as we are now trying to do. So like I said, the problem is that Jim's request is right now, and then we've lost Jim. He may have gone and gotten a coffee. We don't know. And the solution is figuring out how do we stay on the call? How do we keep that brief 100 or 200 millisecond ephemeral connection and expand it to last minutes or hours, the entire duration of that user's session? And this can change the dynamic of our kind of relationship. Rather than Jim controlling every interaction and initiating every interaction, we now, because we have this persistent connection, we can initiate and reach out to Jim and say, hey, Jim, there's something going on that's relevant to you, and you should know about this. And that's WebSockets. So WebSockets, by nature, are long-lived open connections. That's how they operate. So rather than Jim opening this temporary connection that closes 100 milliseconds later, Jim opens up a WebSocket connection, and we keep a long, persistent open connection between the client and the server. This is how chat clients work. So when I message my friend Alex on Slack to say, hey, Alex, you come to the meetup tonight, I don't send a request to Slack, and then his laptop is going, hey, Slack, did Jordan message me? Hey, Slack, did Jordan message me? Hey, Slack, did Jordan message me? No. Instead, Slack is like, I've got an open connection to Alex, and he's online right now. Let me ship that message straight to Alex. And that's a much more efficient approach. So as this data that you see cycling in the background is changing, and because that data is driven by the interactions of all the users on our website, those events can drive messages that we push out to all of our other users that are related to the actions of other users. And so we can start to change the way Snagajob operates. And we can have an interactive kind of user experience in which will improve kind of how our users enjoy our website. So how does this apply to Snagajob? Well, if we go to the Jim and the Susan example, Jim maybe applies. Maybe Susan's Sonic. I forgot. This is Sonic, not Chick-fil-A. Susan manages as a hiring manager at a Sonic location, and Jim applies. We can immediately notify Susan, hey, you've got an application. And we can create a feedback loop and say, as soon as Susan opens that application on her phone or on her browser or whatever, we can immediately let Jim know, hey, someone's checking you out. Somebody's looking at your application. So he gets that instant kind of feedback to know that Snagajob works and is helping you rather than kind of applying and it go into like a black box. I know that I've submitted resumes and never heard anything back. And I don't know if that's because there's just a persistent open position or because I wasn't qualified, but this can help improve kind of the user experience. And so that's where kind of WebSockets comes in. So this makes Jim happier, and Jim loves Snagajob. So a couple months ago, that's interesting, I created this kind of dashboard to visualize data and these events that I talked about traversing our systems at Snagajob. And I created this because some other engineers had come to me and said, hey, you're building this, you just kind of demoed this totally unrelated thing, but we think that we can do the same thing, but with WebSockets, and we can harness these events. Can you help us? Can we do it together as like a side project? So what this is just a dashboard I created that visualizes data or events that are happening and people that are applying at Snagajob right now. So since I loaded this page, we've got 158 applicants. So 158 people around the United States have applied for jobs in the last 30 seconds. So these kind of graphs are just kind of showing how many events per second we're talking about. And there's a distribution that's constantly adjusting on the type of event I'm tracking. This is an example of a WebSocket in action. Behind the scenes here, there's a long-lived connection that is between my browser right now and some server in AWS, essentially. And that server is pumping me 473 and counting, 493, 502 signals or events over the WebSockets. Each one of those is its own individual request, its own packet. I'm receiving that event, and I'm dynamically updating this graph. I'm dropping these pins. And if I click on one of these pins, we can say somebody just applied to Chick-fil-A, actually, in Nebraska, right? So somebody just may have found work at Chick-fil-A in Nebraska, and that's an event. Now, one important thing to understand is this dashboard is called the, whoops, didn't mean to zoom in, excuse me, the live event demo. But live, I discovered as I was building a demonstration for WebSockets that I'll go over in a minute, is all relative. For all you care, this may be 3 seconds ago, and that doesn't matter. It also could be 20 minutes ago. As far as you're saying, the user experience, it appears that stuff is happening right now, and because we're getting this data. But if that data was 10 minutes old, it wouldn't matter. Now, in this case, it's about 3 seconds old, 2 seconds old, somewhere in that time frame. There's a number of things that the events are kind of piping through and stuff like that before they end up getting shipped out to my client here. But in the case of, say, a video game, if every time if I was playing a video game and I was trying to do something, if I had to wait 3 seconds before that thing to happen, that would be a poor experience. I would be very frustrated. And I was while I was building a video game. So where does AWS fit into all of this, into WebSockets? Like I said, this AWS Meetup, but this doesn't have to be just about AWS. But in this case, Amazon released an update to its kind of flagship API gateway. It's called Amazon API Gateway. And Amazon API Gateway can serve a whole bunch of different purposes, but it can generally will serve as a public endpoint for all different types of people connecting to you from third parties, et cetera, or clients or just users to interact with your backend APIs through this kind of gateway. But they added WebSocket support December of last year. And so once I saw that, I was like, I want to know how this works, and let's figure out how we can leverage this. All right, so because I don't have time to do a deep dive, I'm going to push the deep dive to the next AWS Meetup. And in the next AWS Meetup, I can do a deep dive on exactly what the code looks like, how it all works. In this one, I'm going to demonstrate WebSockets in action in a game that I kind of built for this demo, and a couple of other AWS services that all kind of work nicely with it, so you can see kind of how they work. And I'm going to just go over some brief architectural kind of high level how this works, and some of the pitfalls I've run into as I was building it. So demo time. So I created a game called the Snag a Job Tumble Race. They don't pay me to name stuff here, so that's the best I came up with. It's not trademarked, and it can be changed. So the concept is we have gamers, and we have, there's basically 4 kind of pieces as you're playing the game. The data is traversing 4 different layers here, kind of. So I bought some of these NES controllers, wireless NES controllers on Amazon, 20 bucks for a couple of them. I'd never written anything, done anything like this before, but they're pretty straightforward. You put them in, they're a little USB, it's kind of like a wireless mouse. You just plug them in right back here. And they show up as a joystick. Because they show up as a joystick, I can now basically leverage them as a joystick device. And I wrote a Python script, or a little more than a script, but a little program in Python that receives all these events and transfers them. So I'll go over here because there's a bunch of cords in my way. So essentially, if you're using one of these, you press a button, that's going to send a little message over wirelessly, joystick message. I pressed up, down, left, right, A, B, select or start. That's going to come in through this little guy right here, depending on which one of these you have. That's going to get picked up by my Python program I've got running. And 100 times per second, I'm going to ship that event off to Amazon. But I'm going to ship it two ways. One way I'm going to ship it is over WebSocket to Amazon API Gateway. So my Python script will open up a persistent open connection like we talked about. That's going to be the one of the ways that events get from my Python script to the cloud and eventually to the viewers. It will also ship the events 100 times per second to Amazon Kinesis, which is Amazon's live kind of streaming kind of service that they offer. It's a serverless service. And I went deep into Amazon Kinesis 3 different meetups and kind of 2 different meetups ago. There's a reason why I'm shipping to both, but I'll explain that in a second. Then there are Lambdas running in Amazon that are going to receive these events and forward them on back to Amazon API Gateway, which will send the events out to, oh, I just noticed that there's something in the way on this screen here, out to API Gateway, or out to the users who are, here we go, now we can see them, the spectators. So you can open up this thing in your browser. This is all running in AWS. You can load this page. You press a button on your controller, goes through my through this USB device, through my laptop, out to Amazon via 2 routes, goes back through API Gateway, and then it hits your browser, and you can see the result of what you press. So that's essentially the architecture, how it works. Now, the reason why I did it 2 different ways is because originally I just started with Kinesis, and you sent the events, a batch of events, and the problem is that Kinesis is polled, so you can only receive messages at most once per second, and this is where the lifespan of the event, or the time at which it's relevant, matters. A 1 second old event when playing a video game is basically worthless because it's been a second and you died or the game changed or something like that. So then I added in going through API Gateway over WebSocket, and that got it down to 70 milliseconds or so. So between the time you press the button, it goes through API Gateway, goes to Northern Virginia, comes all the way back down here to your browser. That is about 100 milliseconds or something like that, fast. And that's where API Gateway, sending the events over WebSocket via API Gateway was really nice. The problem is that the way Lambda works with API Gateway is I send a message to API Gateway. I can send four button clicks, up, down, left, right. Say they're 1, 2, 3, and 4 in this example. API Gateway receives them, and that will be served by 4 different Lambdas because it scales out horizontally very rapidly. Those 4 Lambdas have different resource contention between other stuff running on whatever host they're running on, and they might process those messages a little bit faster or slower than the other one. So by the time they come out the other end, they might not be 1, 2, 3, 4. They might be 1, 3, 2, 4. Now, in my experience, they're typically in the same order that they go when I press the buttons. But if you're really fast, you can get them to be registered in reverse order or in an incorrect order. And so the other option I sent through is through Kinesis. Kinesis guarantees ordering. So that solves the problem. I have a 1 second delay, but the message ordering is guaranteed. So when you use the right combination of keys, they will always come back in the same order when they hit the user interface. I could, but then I'd have to limit it to 1, and then that would slow down the responsiveness and things like that. So I didn't bother with that. And also, I thought it would be cool to demonstrate the fact that it didn't operate exactly the way you would think. So I was like, okay, this is cool. Let me turn this into a part of the game. So let's load up the game here. All right, the Snag a Job tumble race. Hey, Joseph, are you there?
Yes, sir.
All right, perfect. All right, so we got 3 controllers here. I need to run the game, so let me just start the game real quick. By the way, there are a ton of moving parts, as you could see. So let's see if this, all right, blue, up, down, left, right, A, B. Okay, that was blue. See if this is red. Up, down, A, B, left, right. So these, as you see here in my console, as I press all of these buttons, these are registered. This is what I'm taking, and I'm shipping 100 times per second to Amazon. And then finally, this should be green. Perfect. OK. So if I load up my UI here, you should be able to see. So I'm on green here. You can see the, looks like green is missing up and left. Sometimes these things don't initialize fast enough, and I need to restart them. So let me just restart this thing. All right. I forgot to wait. I have to wake this up before I run my program. Otherwise, it gets a little bit crazy. Left, right, A, B. Perfect. All right. So let me open up the browser. So I should see under green, up, down, left, right, A, B. Perfect. Up, down, left, right, A, B. Perfect. Just throw down, left, right, A, B. All right, so we're in action. All the buttons are registering. All right, so I need some volunteers because we're going to have you all participate and play and see if you can beat my friend Joseph, who is not in this room. He's hidden down in the corner of the office. So you all, because this is an online game. So can you defeat Joseph, who, by the way, has played a fair bit of video games in his life? So it might not be easy. Just saying. So volunteers, anybody who's a good gamer? I want a good gamer, a bad gamer, because this game's a little bit different. I'll explain. Bad gamer. All right, got a bad gamer right here. All right. So press one of those buttons. Let's see what, I don't know which color you are. All right, you're red. All right, so this is blue. All right, Chandler, you're young. You should be good at this. All right. All right, and so we've got green. I'm thinking about putting my friend Jason in here because Chandler is his student and Jason is the professor. So we'll have a little student-professor action here. All right. Okay, so now we're missing our people. We got contemplative Jabari, bored Mariah, manic Nia, and confused Dahlia. These are random names and adjectives I generated. So we got to load our gamers in. So somebody who's red, you sir, already press select start, select start. You know the cheat code. So to be part of this game, you have to get your picture taken. So I need you to give me some sort of face that's not happy. Can you do that for me? Perfect. All right, so I've got this picture of this gentleman here. All I'm going to do is quickly upload it to S3. And he is now going to be loaded into the game. All right, so I'm using a service called Amazon Recognition. And when I upload the file to S3, that triggers an event. That event triggers a Lambda. And I have a diagram of it right here. So basically, when I took that picture, I uploaded it to S3. The file went to S3, and it triggered an event that started another Lambda. That Lambda downloaded the file and sent it off to Amazon Recognition. Amazon Recognition is a service that Amazon offers that allows you to essentially pass it a photo, and it will send you back the bounding box of the face, like here's where the face is, and also what emotion it thinks the person has. So as you can see, my friend over here, where's the game? It's over here on the end. He's 22.5% confused, and that was the highest. Amazon Recognition is stumped by you, sir. It is not confident at all that you're confused, but it thinks more likely than not you're confused than anything else. So now we can do one more thing here. There's one more cheat code. You haven't found this one yet. So the cheat code is, I'm going to have you press start, start, select, select, and then, but before you do that, you have to give yourself a name. So you could use your name, or you can use whatever name you want. It can be Captain Sparrow, or an alias that you use. What do you go by? Name your kids or wife calls you? Boo? It could be anything. Your cat?
Yeah.
Okay, so you're going to press start, start, select, select, and then I'm going to, you speak into this. Ready?
Start, select, select.
Yep. Hold on. Well, so when it will pop up there. When you see that pop up, you talk to it.
Eve Snow.
I am willing to bet it will not get that. You said Eve Snow? Eva Snow. Yeah. So it didn't get it, in other words. So what's happening behind the scenes when he said Eve Snow is I tried to build this a couple of different ways. I started out using a service called Amazon Transcribe, which you send an audio clip to it, and it will give you the text of what they said. The problem with Transcribe is that it is really slow. And so it's a minimum of about 45 seconds to a minute between the time I record the audio clip and upload it and the time Transcribe gives me the data back. And so the way Transcribe works is you upload your audio clip to Transcribe, which is up here. Transcribe will then asynchronously parse determine what the person or what the audio says, drop a file in S3. That's not crop. It would trigger an event, which would trigger a Lambda, which I'd parse that file and then send it out to the UI. That was too slow. So rather than sticking with Amazon, when they don't do something well, just use Google. And Google has something called the Cloud Speech to Text API. And it's something you pay per API call. I have my own little Google account. And as long as I stay below $100 a month, so I don't play this game too often, I will be good to go, and it's free. So I send, when that records my Python app, actually, it detects you press that special combination. It records audio for 5 seconds. It sends it up to Amazon, puts it in S3 bucket. That triggers a Lambda, which ships it off to Google API. Google responds and sends the event through my kind of event stream, and it comes down to the user interface and will update the interface. So what I'm going to do, would you do one more time? You said Eva Snow. All right, try one more time. Start, start, select. Oh, yeah. I own that movie. It's a good movie. So Eva. OK, so start, start, select, select, right? Yeah. Eva Snow. See if Google's any better this time. If that doesn't change from a shruggy emoji, Evil Snow. So he thinks it's your Evil Snow. That's pretty good. That's a pretty good name. All right. OK, so next up, we've got Chandler. Right? You're blue? Doesn't matter. Select start to select yourself, sir, please. Need to take a photo of you, my friend. Let's do really whatever you want, man. I'll delete these photos. They're not, I mean, you don't have to worry about them. They're not going to be on social media. All right. Got him. All right, so. All right, been uploaded. Boom, done. All right, Chandler, do you have a alias, handle, et cetera, when you play games online? Oh, no! I uploaded the wrong one? Oh. I'm disappointed. There we go. There it is. Sorry, I must have uploaded his again. OK, so right now you're sad Mariah. You probably don't want to be sad Mariah. It does think you're sad, though. 60% certain that you're sad. So good job. So we need to give you an alias. So it would be start, start, select, select, and then
C-long.
Did you wait for it to pop up? I might have to, it might just get what I said. We might have to do that a second time. I might just say, did you wait for it to pop up? Sad Ceylon, did you wait? Perfect. All right. OK, so that's good enough. All right, so Mr. Trinkline, you're last, sir. Select start, select start. I'm going to have to get a nice photo of you, my friend. Yours might end up on social media. All right. Jason, you could be happy or whatever you want, man.
Manic?
Manic? All right, got it. All right, you're selected. Okay, select start, Jason. There you go. All right, boom. Now we're selecting Mr. Jason. So as you can imagine, he's joyous. Apparently, they think you're very happy. Okay, so joyous Jason, I mean Nia. All right, but you can choose your handle. So this is going to be start, select, and then your handle.
Invader Zim.
All right, Invader Sim. That's Jason's favorite thing. You know, he has a million cross stitch this big that's just of Invader Zim in his house. Joyous Invader Zim. Boom, perfect. So Google API working like a charm. All right, so now we have our competitor, Mr. Joseph. All right, so how do I bring up, let me see if I can bring up Zoom and show. So there is, so the front end is written in like JavaScript, TypeScript, and the browser is connecting via WebSocket, and it's keeping that open connection, and it's receiving messages directly. So yeah, so I have code that when this page loads, it executes code that connects to the WebSocket right then, and it keeps it open, the duration of this page being open. So that's how that works. So hold on one sec. Let me fix. I'm not good with stuff other than DevOps. So give me a second to figure out how to get Joseph up on the screen, because apparently, Joseph, I'm trying to, not QuickTime. Yeah. Oh yeah, that's what'll work. That'll work. I'll do that. Here we go. Okay, so Joseph's over here. Let me just bring him. There he is. Hello, Captain Joe. All right, so can you hear me, Joseph?
Yes, sir. Loud and clear.
You said select start, select start. So what we need to do is take a picture of you. So I need you to give me, let's see if we can do picture and picture and picture. All right, I got you smiling. So let's see how certain. This is very pixelated, so I'm not sure what Amazon is going to think about your photo here. Boom. All right. So Joseph should pop up here in a moment. And Joseph, I also need 79% calm. That's not bad. It did a poor job of cropping your face, Joseph. It had trouble figuring out. So it's just got your head. I hope that's okay. The top of your head. So Amazon recognition did a poor job of recognizing Joseph's face, but we've got him there. So that's what matters. So Joseph, I need you to also do start, select, and then just say into the microphone what you want to go by.
Okay. Peter Pan.
Peter Pan. Okay, Google, show me your worst. All right, Peter Pan, perfect. Okay, so before I bought the Nintendo controllers, so I was laying in bed 2 in the morning, woke up, this is where crazy ideas come to me, and I was like, I'm gonna make a game, and I don't know what I'm gonna do, but I know there's gonna be bars sliding and there's gonna be clicks. So I bought 5 of these dash buttons at $25 a piece, thinking that these dash buttons would be perfect for this game, and I would just give you a dash button, you just go, can I click faster than the next person? The problem is the dash buttons don't, well, first of all, they're limited to 2,000 clicks on their battery life. But the biggest problem is they go into sleep mode and they're disconnected from the Wi-Fi. And then when you click the button, it takes about I just clicked it, by the way, 7 or 8 seconds, 10 seconds, it connects to Wi-Fi, and then it will finally register, and then it turns itself off again. So it's not good for this type of game. So I abandoned that pretty quickly, but I had all these dash buttons, and I was like, what the heck am I going to do with these? So if you notice that blue bar at the bottom went away, it's because I clicked this button. All it does is removes the blue bar. I have another dash button that can pause and unpause the game, and you all can begin your battle as using, you got to hit, okay, so I forgot to explain the game. So I should explain the game first. Otherwise, it won't work very well. And Joseph, who has played it before, will have a very big advantage. So the way the game works is when I press this dash button, that's going to change this paused at the top up here to not paused. It's going to have a series of It's going to say left, right, up, down, A, B. One of those things, and there's going to be 4 of them. So it's either going to be like up, left, right, down, or up, left, BA, something like that. So the concept of the game is you want to press the combination, and it's kind of like a cheat code. You want to type in the combination as quickly as you can. Every time you get it right, your little dude is going to move to the right one. Now there's 2 bars here. The top bar is is going to be the button presses that go through WebSocket. So they're very fast. They'll register very quickly. But if you go too fast, they might come in to the UI and not the order you pressed them. And if you make a mistake, you're going to tumble backwards. So you want to go at the right pace and tumble forwards. It's a tumble race. So your guy's going to tumble forwards. Now, the bottom bar is your power-up bar. It's purple. It's for kinesis stuff. So that stuff is guaranteed ordered. So you are rewarded for not making a mistake. So slow and steady might win you the race. So you got to choose tortoise or hare here. There's like it's a strategy. So when I unpause it, there will be 4 arrows, or not arrows. They'll say left, right, up, down, A or B, and you'll have to press those. Now you have 1 extra piece. You have the opportunity to do select start BA. That's your secret code. And what that does is it changes what everybody's supposed to press. So you can reset, and nobody knows when you're going to do it. You can reset the combination everybody has to put in, and everybody can do that once. So this check mark will become consumed once you have done it, and you will no longer be able to reset it. So the goal is to get to the end. You got to get 40 correct in a row. Once you get 40 correct in a row, you'll win. I also have a dash button to reset the game because I have a bunch of them. So it takes a while to onboard everybody and get all their images and everything in there, so I figured I needed to do that. So I'm going to unpause it briefly. There will be a combination, and you will be battling against Joseph. Now, if somebody gets close to the end, be careful, because somebody might actually reset the code, and then you're going to start tumbling backwards if you don't notice fast enough. One last thing. These are Amazon discount Nintendo controllers. Sometimes it feels like you're pressing down or left or up or right, but you might hit down right, down left, up right. So you'll swear you're doing the right thing, but you're actually not. So be careful and press just the edges of the gamepads. These aren't high quality PlayStation 4, 5, whatever's out there these days controllers. Are you ready? Now you're going to get to see what latency looks like when I press this button. Okay, so I'm going to press it now. All right, okay, all right, it's green. Nope, not green. It's green. Go! It's up, down, A, B. That is the combination you must do. You're tumbling. Joseph's good, dude. You gotta, whoa, no, Joseph. Up, somebody changed it. Somebody swapped it. It's right A up, folks. Right A up. Oh, no! Left up B. Left up B, left up B. Chandler, the youngest one, of course, is in the lead. Oh, it's been reset by Chandler. Left up B is still the combination. He got a power up. He's very consistent. Oh, it's right up now. Somebody changed it. It's the battle. Right up, folks. Right up. Oh, Calm Peter Pan wins. Woo. Who would have thought the person who had already played the game before won the game?
Nailed it.
Okay, so so if anybody else would like to play, we can reset it with this other dash button. I think it's this one. So dash buttons have 2 functionality. You can click once or click twice. That's a double click. So I'm going to double click it, and it's going to send everything back, and it's pausing the game. So if anybody else would like to play, we're not going to retake photos because that takes too long, but we can. I know Mike wants to play. Chandler? All right. Joseph, you got to play again, my friend.
Roger.
All right. So I am going to unpause it, and now, and we'll just wait 9 seconds. 7, 6. Oh, it actually went faster that time. Right up. Right up. Oh, Invader Zim. Uh-oh, people are having trouble here. Joseph is up, right, left. Joseph already swapped it. Up, right, left. People are struggling. We can do this. Invader Zim is somehow up, right, left. Oh, Invader Zim. Woo! Mike, of course, Mike wins. The man loves old school video games. So, I'm sorry. It can be with that. Okay. So,
one thing I was curious about is like, what if it was detecting, like it was up, right, left continuously? What if it started detecting at the wrong point? So it was continuously seeing right, left, up.
good question. So you would, okay, so if it was continuously seeing right, left, up, it doesn't work that way because every time you get dinged as like you lose a point or you gain a point, it resets it and it's like coming back from nothing and then it registers the next 3. So if you do one wrong one, it resets it. And every time, I have to look at the code again because it's been a little while, but basically it does not actually work that way. If you get it wrong, it's not going to continue to detect the wrong thing. It will, or should, continue to keep track of where you are. So if you get a wrong combination, it will roll you back and you start from square one again every single time you get a wrong one. So that's a good question. My guess is yours was like spinning on the left side, and you were like, "I swear to God." So let's reset it and see. I mean, it's possible I have a bug. I'm not going to sit here and act like I'm perfect. So it's possible we have a bug here, but you are welcome to try again. I'll reset it, unpause it. Let's debug my application live. Okay, so up, right, left. Try that again. So I see up, right, left, up. Up, somebody changed it, of course. Right, up, right. So try up, right, up, right. No, that's what you, sometimes if it sends 2 in a row, it's revealing what the most recent click is, essentially. But sometimes when you press right, if it registers up and right, it's going to go right up or up right, and then it'll look like you just said right, but it's actually registering up behind the scenes. I'm not going to say it's perfect. There could be a problem. It's I made it for an AWS Meetup. You know what I'm saying? So like, you know, it's not, this isn't for sale. This is not a pay for thing. Yeah, I know. Yeah, it's totally possible. Here's how we can be certain here. If I refresh the page and unpause the game, and we're going to lose all of our people, but you can see it's going to be up, down. What is it? I don't even know what it's going to be. But it's going to be one of those codes. Oh, see, it got a red, so this thing sometimes fails to connect to Wi-Fi, and you have to press it a second time. These things, don't buy. It's not good. It's a waste of $125. Up, down, AB. See, still not working for you. Are you number 2? Are you blue? I'm inclined to look at the terminal. All right, I see blue. Vert neutral. Oh, your up key broke, man. Your up key's not working. I apologize, man. So it happens every once in a while, and you have to disconnect it and reconnect it. So that's what happened, I think. I think that's what happens. I didn't see any ups. It may be. Yeah, it might be. But we'll see. Anyway, the one last piece is how the dash buttons work. So I have a quick example diagram here. Well, I thought I had a dash. Oh, I don't have it, but it's somewhere over here.
What's the cost of opening up a WebSocket? Performance,
Yeah, and I can go a lot more into detail. Sorry, that's work stuff. I can go a lot more into detail the next time I do a deep dive. But so what you know, for what it's worth, API gateway, the real advantage is that it manages the WebSocket connection for you. And so you create the connection, you have a Lambda that handles authorization, authentication. So you have control over what data goes back and forth over the WebSocket. All it does is just handles the servers that keep the connection open. So in terms of authentication, security, things like that, that's all just, it's a secure WebSocket connection, so it's by default, it's all encrypted data. Amazon has that. But the authentication or authorization, you handle in your own code and your own Lambda. So right now, to connect, I have authorization kind of turned off, or authentication turned off, because this is just like, there's nothing valuable here, like no data I'm concerned about. But that's kind of how that works. Now, in terms of pricing, it's pretty reasonable. For this, it would be, browser performance? Oh, so the UI I loaded a little while ago, I've had get literally hundreds and hundreds of requests per second. And I didn't, I mean, my browser was rendering all the graphs and it wasn't much. And it's really the performance was the live rendering of the graphs and not so much the performance of just receiving those messages. Yeah, I mean, I'm sure there is a performance side on both if you're parsing these JSON messages, at a high rate. But my laptop, at least, is a pretty powerful laptop. I didn't have any problems. So the pricing is every 1 million messages you send over a WebSocket, it costs 1 cent. So it's pretty cheap. And then it's also, it's both. So the connection, every very large number of minutes, I don't know, 1 million minutes of open connection time or something is also like a penny. And then it's every million messages, it's a penny, something like that. So it's very inexpensive. Now, if we implemented it on Snagajob and every single user on our website, so we had 5,000 or 10,000 concurrent connections and we were sending tons and tons of messages, that would obviously become something. This is kind of Amazon's model, right? You're like, oh, it costs nothing until you're at scale and then it costs something, right? So, but I looked at our bill and I ran that UI and that thing's receiving thousands and thousands of messages. I've probably run it for dozens and dozens of hours and I think our bill was like 2 cents. So it's pretty insignificant. And I had shared it across the company. Other people had been running it and all that stuff. So yeah, that's pretty much it. Anybody else have any other questions? Yes, sir.
So on the front end, how are you tying these WebSocket API, like the JSON kind of
right.
Like sort of blog that, and so how are you interfacing the WebSocket API in the browser to the web app, like the React or this?
So this is Angular, and I'm just, to be fair, I don't do UIs usually. Like this was the first time I'd used Angular. Yeah, thank you. So it was the first time I really used Angular. This is Angular 7. So, but basically the great thing about Angular is like, you just change the model and it makes the stuff happen. And I have some dynamic CSS with CSS variables, but I can't give you a really detailed answer. All I know is I've got a service that I've written in Angular and I'm basically injecting that service into my Angular component. That service is the WebSocket service and it's the one that maintains the connection. And whenever those messages come in, my component is essentially what's got doing all the controller type stuff for the page. And so whenever messages come in, I just change the model behind the scenes and then things happen. That's the best I can describe it. No, I haven't. No, I mean, I have not looked at that. I basically just, I've heard about like gRPC and all that kind of stuff, and I've done some like server side stuff with like service mesh and whatnot, and like gRPC and on Linkerd and whatnot. But I've never actually like leveraged it for a particular use case. I've always done basically HTTP and then now basically WebSockets.
Yeah, not through WebSockets, but getting intrigued by the idea of having this browser
Right. Yeah, I mean, the thing that drew me to the AWS solution was it's very simple. Basically, they manage the connection, and if you want to send a message to a particular user on a WebSocket, so I just have behind this, I have a database table with all the open connections. And when I get a message that one of those connections is interested in, so I'm keeping a track of like, here are the open connections, and this connection is interested in this, and this connection is interested in this. I make an API call to Amazon and say, hey, send this connection this message. And Amazon sends the message over to WebSocket. So I'm just interacting with a basic API, and I'm managing the kind of connection store, the database of connections. But Amazon's handling like, I've got this, I say, this is the connection ID, send this JSON to it, basically. That's how it works. That's the great part. I don't have to worry about it. That's the beauty of API Gateway with WebSockets. It's like I don't have to worry about any of the scale. So I can scale like insane. Like that UI I showed right there. I mean, not that one, but the previous one, like I have run some numbers on the scale, but like Kinesis is behind the scenes, and that's what's driving all the messages rather than the messages coming from users clicking and that coming over WebSocket straight to Lambda. And I can just scale Kinesis out to like 1,000 shards, and I can have Lambda consumers, and each one of those processes and takes a batch of connections like, oh, this needs to go to this one, this needs to go to this one. So it's very easy in a serverless way to scale horizontally very rapidly, using the stack. So it's pretty cool. And if anybody wants to know how the whole recording thing worked, I couldn't find a Bluetooth microphone. So like behind here, there's a pumpkin that's holding a Bluetooth headset. The Bluetooth headset is right next to the speaker. So when you spoke into the speaker, it went out through there. My Bluetooth headset picked it up, and then the Python script listened and then shipped it out over. It took a while to get it like exactly right. Yeah. Yes, sir.
How long did all this
I started about 2.5 weeks ago, and I've been working on it. I probably put like 40 hours into it. Yeah. So it was a bit of a learning curve, like the Angular stuff. I had already done the previous UI, so I had some experience with a lot of experience with WebSockets, and I have a ton of experience with AWS services and everything that's behind the scenes making this all work. And the Python, like I write Python every day, so a lot of it's all basically Python that's making it work outside of the TypeScript, and Angular for the front end. So. Yeah, so I have him. It's a GitHub repo. He just checked it out and ran it locally, and he's got a controller and he's plugged in to his USB, and so that's how it's all shipping. Yep. So he's my teammate, so we have similar credentials and everything. So it's all just using the same authentication for AWS, et cetera, that I'm using. Any other questions? Tomas, nothing? He understands everything. He's like, I got this. Oh, okay. Cool. All right, well, that's it. Thank you all for coming. We appreciate it.